back to the Talking with SOT podcast. I'm here with Harnek and Ian. As always, we have two special guests.
We have joining us Justin Gullison and third timer.
Wow.
Third timer. Is this our first third timer?
Quite possibly.
I think you're our first third timer. We have Alister Lopes.
He's a staple. He's a staple.
He's a staple
of the podcast.
You might
feel
need
honored
a
and
third
privileged to be on.
coat now.
What's that?
We need a third time coat now.
We don't
Yeah.
get coats out. Are you
Oh.
kidding?
Can I get a pin or
Maybe
something,
a
or like
coffee,
a-
but
We got to hey, thanks.
Yeah, okay.
I've been missing
Handshake
for
form. Thanks for coming out.
I like it. So we have you said Justin Gullison, but I didn't know who that was.
Yeah,
at
who's
first.
Justin?
Like isn't it Gully?
Justin Gully Gullison the third.
Yeah.
Is that
Yeah,
what it
so-
is?
The third?
Yeah, the third. Yeah, it could be. There's a long generations of
dynasty.
gullies.
There's a long. So we have Justin Gullison, who used to teach on our side with us. And when we say our side, the School of Transportation has the, I guess, apprenticeship side and the motive power side. And you've recently spread your wings over the motive
the dark
power
side.
Traitor.
It's got LED lights. It's pretty bright over there.
It's actually bright.
Yeah, it's way
nice
brighter.
over there.
But we refer to it as the dark side.
It's true. It's true. So you were known here as Gully.
Yeah.
What are you known there as?
I'm a hybrid over there. Gullison, Justin. Some people call me Gully.
Some people do? I
Yeah.
thought, okay.
Yeah, some students call me that. Oh, I don't think they heard someone else calling me, and I think they just shortened my last name.
Gotcha.
And
Yeah.
just had become that as well.
Well, now that they listen to the podcast with you on it, I hope it sticks.
Well, I think it will.
What do you prefer?
I just
Call me
yeah,
Your Royal Majesty
probably-
Gully the third.
Yeah, probably
Don't call me
Gully.
late for dinner.
Yeah, probably Gully because that's what I turn around to the most.
Okay.
All right. So Gully, we're going to be talking about AC fundamentals. But we had a cool thing happen at the college today. So we're at the college on a Saturday, which is weird for us.
Mhm.
And we were just at skills. We all participated, or not participated, but helped run the skills challenge for Centennial College. And I think it was a pretty productive day. What do you guys think?
It always is, yeah.
Yeah, it's always been a pretty good.
So for anyone who
event.
doesn't know, the skills competition is just that. It's a competition where individuals can come in and showcase their skills. We set up multiple sections: engines, drivability, drivetrains, electrical, SSB. So it's in line with the courses that are run here. The different programs all have different skills competitions. There's one for the body shop. There's
two for the body
two
shop.
for the body
Yeah.
shop. There's the
Motorcycle.
motorcycle program that has its own skills competition.
sports, I believe, yeah.
Power sports.
Heavy duty truck, I believe.
Heavy duty and
Heavy
truck
duty
coach.
and trucking coach.
Yeah.
Yeah, I always throw those together.
Yeah.
So there's, regardless of what program you're in, you have an opportunity to come in and compete. And it's a fun time for the competitors as well. It's a great opportunity. If you're successful here, you move on to provincial skills. And from provincial skills, you go to national skills. And from national skills, they run, and I just learned this today, they run
Worlds.
world skills
Yeah.
every 2 years.
Oh, is it? Okay.
Yeah, so it's every 2
okay.
years, and the skills competition is in Lyons, France.
Oh, wow.
So
Cool.
that's where it's going to run, and they'll take you down to France, and it's
I mean, how do I
great
get involved in
opportunity.
this?
What's after World Skills? Universe?
Universal
Universe,
skills.
yeah.
Yeah.
Space Force is going to take us up. Yeah, it's perfect.
Talk
but-
to Elon Musk on that one.
Well, yeah. What a fun day, though.
Let's have him on the
Yeah.
podcast.
Yeah, I mean, that would, I could make a joke about it. Anyways, it was a fun day. Like, you get to see a lot of students put themselves out there. So if the level 1 student, Matthew, listens to this, what a great job. He came
Yeah.
in and he was so frustrated with the electrical portion, and he just sat down and then dug through it. And I was so impressed with him. So,
And really,
You know.
I have to say, I'm really proud of all the competitors
yeah.
because it does take a lot of guts to show up and compete in
For
something
sure.
like this,
Absolutely.
especially those level ones who they haven't even completed all their
Some
courses,
of the courses,
yet.
yeah.
Yeah.
So they're coming in, just like you said with Matthew, they're maybe a week or two into electrical, and then you have an electrical problem in front of you, right? So it
I
is.
will say, if you listen to the podcast, it will help you.
Oh, absolutely. Yeah, I know. So
Actually-
a good chunk of the people who are setting up for skills are guests on the podcast,
Yeah.
and that's kind of what we start talking about.
Yeah.
But yeah, no, it was cool to see because even in past years, I see a couple students, bunch of students that show up for skills. I don't recognize many of them, but this year I saw quite a few of my level 1s, a couple other students that I've seen around the college. So it's for anyone. You don't have to be a level 3. You don't have to be on the tail end of finishing a course. If you want to come and experience it, by all means, it's open to everyone, which is great to see everyone trying out their skill level to see where they stand.
And
No,
the biggest advantage is if you competed the previous year.
Yeah,
So if
absolutely.
you're thinking as a level 3, oh, okay, I'll compete. You absolutely come in and compete. But if you competed in while you were in level 2 and level 1, it gives you, I think, the biggest possible leg up.
Yeah. And if you pay us enough, we'll give you answers for the next year. But
No, it's definitely a great experience to add to yourself, just to have and do. I saw a lot of repeats as well from Motive Power this year.
And you ended up with a certificate, something you can throw on a resume, show an employer. And employers love this stuff because they want to say, oh, look at this employee I have here, right? They want to sort of show off a little bit.
Yeah.
And I see that, in all honesty, at my dealer, my fixed operations manager, as soon as he introduces me, he's like, oh, and he's a professor at the college. It's like the second thing he mentions, right? It's after my name.
Yeah.
So it is definitely something an employer is going to encourage you to do as well, and something that will benefit you in the long run.
I was talking to a student earlier this week about confidence, and I think it also helps with confidence. Well, it could help or really hinder, and hopefully it helps. Don't let yourself get down from some of these things because it's made to be difficult. But if you go into this and just try it, the confidence, your confidence level should rise from that. I really think so, because you're putting yourself out there in this trade where you have to be confident to call different parts and actually diagnose some things. I think it really helps with that.
For sure.
You're your own enemy sometimes, so do your best and give it a go.
You're your own enemy?
Yeah, sometimes.
Sometimes?
Yeah.
Or all the
your
time?
worst, yeah exactly.
You're my enemy.
Yeah,
And for the fight portion of the podcast,
This is going to turn into a video broadcast.
we gotta switch locations.
Please
here.
go on YouTube now to watch Mr. Lopes and Mr. Gullison fight.
it's the warm up for I think Tyson's about to fight
Oh,
Jake,
yeah.
YouTube guy.
Jake Paul or whatever. Yeah.
You'll be the warm up fight.
Yeah.
And just warning people in advance, we are in a lab today because we thought we'd do it in one of the lab settings. I think it's kind of fun, the podcast that is. So if you hear some creaks from the chairs or bumps from the desk,
Or the
we're
fan
not
coming
in a
on.
normal room, which I think is kind of fun. And also I've been asked by a bunch of students to make it video and put it on YouTube, which would take a lot more work, and I'm not sure if I'm up for that. But if you want that, I need an email. I've never gotten an email about the podcast except for Chris Muir, which I appreciate.
I'm going to send you an email right now.
No, not you guys, a student or somebody.
It's more so the students yell down the hall.
Yeah.
Oh,
It's
I have
put it on
ideas about the
YouTube.
podcast. Yeah.
But if you want a video on YouTube, then I need emails. So we'll see if that does anything.
They want to
Good luck.
They want to see you guys talk.
I think so. I
I
think
guess
there's-
this makes it a little bit more interactive, I
I
suppose.
see.
yeah, so we can set up a couple cameras possibly, but then I need to
Freshen up. You got to get the
yeah,
makeup going.
man, I don't look good at all.
Well, we've been here since about 8 o'clock in the morning, and it's close to.
It
is
usually
5:36
goes that
now?
way, too,
Yeah, so
yeah.
I
we
started
do like
with
a
my
long
shirt tucked
day.
in. It's no longer tucked in. I'm
Yeah.
like, that's it.
Letting loose now. Mr. Gullison's just waiting for the beers at Cornerbank.
Maybe. Yeah. No comments.
Maybe. I mean,
No comments.
I'm innocent.
I love it. Well, it was a great day, and congrats to all the participants and the winners. We had some guys that scored very well. I know from Mr. Gullison's side in automotive anyway, you had two guys place on the podium, and we had one over here. So
Yeah.
And it was close, right? I believe it was
Well,
really
close.
6%.
No,
different. Oh, sorry,
0.6.
0.6%. Sorry,
Yeah.
0.6,
between
wow.
first and second place.
Yeah.
It was that
Yeah.
close.
And actually, the person who won first place, they did it last year, and big improvement. So it helped.
There
it
we go.
definitely helped. So there you go.
Yeah, really fun to watch. So I challenge all of our future students or apprentices to give it a shot. And it's under 29, I believe, right?
Yes.
Under 29.
Well, there's no age limit for
Centennials.
Centennial,
Yeah.
but to move on to the next level of it, provincial skills, it's under 29.
Yeah, so if you of any age, come try it Centennial, and I think it's just a bonus.
So if you have 30 years of experience
Yeah,
in the
that's
shop,
you might have or you could be the opposite and have all the
Sure.
bad traits that
Yeah.
you that you know. So
I brought my own sledgehammer. Don't worry, guys.
I was talking to somebody. I was talking to Sean, who I did the electrical part with. We had meters out, and I'm like, I should go get like the biggest hammer we could find and put it beside the meter as the electrical portion, and see who picks up the hammer first, and see what happens.
You know what? I'll be honest. What I did was, so we have an on-car concern with the brakes. I did put a meter down. I put a set of extendable leads down,
Nice.
just
to throw them off,
just to kind of see what they're gonna do.
Throw a
It's more
scope
for my.
there, yeah.
You know,
I'd like
it's
to
more
know
for me.
how many
Yeah.
students looked at that and go,
A lot
I
of
didn't use
students
this.
picked
What
up.
is this
A
for?
lot
Like,
of
what did I need
students
this
picked
for?
up the meter. They looked at it and kind of a funny look on their face, like, what? And then put it down. So to their credit, they were.
I mean,
they
if
just
we're in electrical
checked
and they
that
pick up
everything
a
was there.
hammer, we're in trouble because that's just light boards.
I mean, that's where I keep my hammer, in the electrical drawer.
That's true.
Doesn't work,
So I
hit
can
it.
Smash that
Yeah.
module.
We just shake that tip 'em, right?
All right. The TIPM is the total integrated power module or something like that.
Fuse
Yeah.
box.
So AC, I think one of the top requests, mainly because I teach it and whatnot, is AC and kind of the fundamentals. So I'd love to chat about that. You guys have all, Mr. Gill has not taught AC before.
Teaching it in a couple weeks.
Oh, sweet. And then Mr. Gullison and Mr. Lopes have taught it throughout the years.
Quite a few times.
Oh, and I've taught it to the body mechanical guys, but it's
Very
a little bit more simplified.
basic, yeah.
More in line with what we're going to talk about today.
Yeah, I think the fundamentals will be good, and then maybe we could come back and do a level 2 where it's kind of diagnostic based or something like that. So,
yeah, I'd love to.
when you
I'd be
think,
on 4 times now.
Oh my God.
Maybe they'll have that track.
I'm going
ready
for the
you.
record now.
D'Amico
For the
will be,
5th time, we'll get you the shirt with the 5 stars.
Okay.
There you go.
inside joke there. D'Amico will be fighting you for that
Yeah.
spot, though.
Yeah.
Yeah,
Oh, but we get them both on.
to fight with Gullison
Again.
in the middle.
Yeah.
That'd
No,
be interesting.
put me on with Jay, and then that'll be he'll still be one under me.
You see that? Alister's plotting.
All right. So when we talk about AC fundamentals, what are some of the main key things that you think of, or what's the start of AC? What do you guys kind of teach?
That is a great question.
It is. That's,
I'll ask
the question I'm asking.
They're all great questions.
I will ask you a question I heard a student ask
Okay.
once. Okay, so after talking about AC for a little bit, his question was, what does air conditioning mean? How is the air conditioned?
Okay.
Oh,
Oh,
Okay.
interesting.
So one of the first questions I ask my students when I start with AC is, okay, what is the purpose of an air conditioning system? Whether
Mhm.
it's your household air conditioning system
Yep.
or your car air conditioning system. And most of the time, most students will throw out, to cool the air. Great, it does cool the air. But in terms of your student's question, how does it condition the air? It is a great tool at drying the air and removing moisture. I think that's a big part of what it's doing to the air. And especially in a car setting as opposed to your house setting, that moisture is no good for when you're driving around.
does it
Absolutely.
actually cool the air though?
Well, it'll decrease the temperature.
It decreases it. Yeah, because the whole system
Sure.
of AC is removing heat from the
Yeah.
car,
Yeah.
right?
That's where I was
Where's
kind
it
of
going?
getting at. Like, are we actually blowing cold air, or is it the absence of heat that you're feeling?
Yeah,
I think
that's
it's
Ooh, getting
Yeah,
metaphysical
that's like-
here.
Yeah.
It's like which came first, the chicken or the egg?
Sure.
yeah. A lot
The
of
chicken,
students,
obviously. Dude. What are you talking about?
Yeah, a lot of students think we're just adding cold air. I'm like, yeah, are we? Or are we taking away the hot air? Actually,
Yeah.
is that how this basic principle is actually working?
Well, the way I look at it is if you're sitting in your car on a hot day, it's hot outside and it's hot inside the car. And all of a sudden you get cold air when the AC is turning on. So it is eventually cooling the air to a certain degree. And in that process, we're also removing a ton of heat from inside the car.
Yeah, and
And
I
it's
think
the process
I think,
of how it goes about it. That's the way I look at it.
and I agree. But I think the way I've taught it the last little bit, I've taught it a few times this year only, so I'm fairly new at this ish. We need to get Tom Brown here for this,
Mhm.
and for those.
I feel like
students that
even
remember,
Jay would love to talk
He
about
would
once we
totally,
get
yeah.
talking about,
the
equalizing
science of
pressures
stuff,
and nature wants a balance.
But I think if you have to think about what heat is, right? Heat is there, and are we actually blowing cold? And I don't think we are. I think we're pulling that heat out so that you're feeling the temperature change, right? Because what happens in that evaporator?
Well, we got cold
We're
refrigerant flowing in.
Pulling the heat out.
Yeah, have a
We're
change.
using that heat transfer from the air into that change of state that's going on in the evaporator to take that heat away.
Yes, but
I can see both sides of this, and
Well, and I love this chat because it's kind of like I feel like we're not professors in this instance. We're more of like technicians chatting.
yeah.
You know what I mean? And I think if we take it as that, and those listening kind of take it as that, don't hold it to us. Jay's gonna be like, "You guys suck."
Trigger warning. Yeah.
Trigger warning.
Yeah.
You could look at it both ways. I totally get both views and both points. But again, if you take away the refrigerant in the system, then there's no heat exchange. There's no cold air coming in.
Well,
right?
Yes, because then there's nothing moving, right? We need that refrigerant, which is constructed that way to change that state of that moment, right? To pull the heat and whatnot.
I guess my question is this: if I take the heat out of the room, have I not made the room colder?
That's kind of where I'm.
That's what. So regardless of which way you look at it,
and if you're moving,
the end goal.
If you're moving air that has that temperature change to it, it feels cold.
It's because it is cold.
Well, is it?
It is because the temperature has decreased.
It's colder, fair enough.
So, right? So the temperature has decreased.
Yeah, just like you have a cold ice cup of water on the table.
Water, eh?
That was like a cup of water.
A glass of cold water will eventually warm up to water to a room temperature. You know, it's kind of.
And then, are you making the water?
Oh, is that?
Are you making the water
to
hotter, or are you making the environment colder?
Interesting.
Well, there's also the saying that heat always moves from hot to cold, right?
Mm-hmm.
So that's what we talk about for fundamentals of AC. And
which is what?
What do you mean?
Which is what are those three kind of heat fundamentals?
But I would also interject: if hot moves to cold, then cold must move to hot.
No, it doesn't go that way.
It can't.
Because when I say that in class, and then I talk about the different aspects of the AC system, so the evaporator gets cold refrigerant that goes in, and then we blow hot cabin air from inside the car over the fins of the evaporator, and the end result is that cool air that comes into the car. But at the same time, the refrigerant that is now leaving the evaporator has absorbed heat from inside the car, and now it makes its way to the front of the car, which is the condenser, and that's how we can get rid of the heat, because we cannot destroy heat, we can only expel it. So
we have to move it.
Yeah, moving it. So that's what we're doing with the AC system. We're moving heat from one place to another, and in the end result, we end up getting nice cold air inside the car. Hopefully.
Yeah. Or a nice temperature inside the car, right?
Yeah.
That's circulating through the cabin.
Okay, so we mentioned some of the components there. Why don't we
go through some of them? Let's
go through
before
all the
we go through that,
components.
there's three types of heat transfer.
Okay.
Do you know what I mean by that?
Like conduction, convection, latent heat.
And radiation.
Radiation.
Right? Conduction, convection, and radiation. And that's a big factor in this too. So I'm thinking about my slides, kind of what you go through. And that you have to kind of hit that first because of how like an evaporator or a condenser, which is some of those components will work, right?
Yeah. Yeah.
And Gully, what do you think? How does an evaporator work? What happens with it?
Well, that's one of the things. We have a change of state happening in there.
Hence the name.
Yeah, evaporator. And
that's the one thing about AC.
Yeah, it's
everything's
nice.
in the name.
Yeah, exactly. and I know a lot of students, they have a challenging time remember what's happening where. And I always go back to, well, look at the name. What's happening? Right? What's it doing?
It's being an H valve. There's H's in it.
I think there's H's. Yeah, the one thing that's not in the name. Thanks.
Yeah, exactly.
I had to.
But the technical term for an H valve is an expansion valve, right? So yeah, it's just the lingo that we give some of these components.
Yeah, well, that's the thing I find in automotive is there's going to be a lot of names for the same kind of component. But, you know, the evaporator, the gas is evaporating, you know, condenser or condensing, changing state in those two places, the evaporator and the condenser. And then I say as well, like there's two places we change the pressure, the compressor and the metering device. The pressures change.
Yeah.
So we're either going from high to low or low to high, or we're going from a gas to a liquid or a liquid to a gas.
So you can almost put it in like a quadrant of four different spots.
Exactly.
Yeah.
So, you know, we could draw it out. We draw all the components out, and then we section it off and like, okay, two places have a change of state, and two places the pressure changes.
Where do you think the start of the system is? And let's go through the components, but let's start at like the beginning or the heart of the AC system.
That's exactly where I start.
Oh, is it?
The heart. Well, I always think of the compressor as the heart of the system.
Okay.
It's pumping.
Is it?
I feel like it's pumping, building
Okay.
up pressure. That's
Does it build up pressure?
that creates pressure.
Does it create pressure?
Are we going into another?
I'm curious.
Well, it builds. It goes in as a low pressure gas and comes out as a high pressure gas. So
How? So does the pump create pressure? And this goes for any system.
Flow.
Yeah. The pump is part of the pressure creating system. You need something else to be there.
Restriction.
Right? Exactly.
SSB.
I mean, any principle is that,
that's
right?
true.
So whether it's SSB or anything.
Right.
So the pump kind of starts, it promotes that pressure almost. And I had a couple students kind of do the same thing. They're like, well, it is creating pressure. I'm like, well, if you didn't have a restriction, there would be flow,
anything,
not pressure. But then if you didn't have the compressor, you wouldn't have pressure with just a restriction. So I think it kind of works in a
it's both.
tandem.
It's one of those
right?
things,
Yeah.
again, like you said a little bit earlier, the way technicians describe it versus how professors get into it, right? Very casual lingo at the shop when we just say compressor pumps,
yeah.
but it's not 100% accurate.
Yeah, we kind of sometimes maybe give them the meat and potatoes of it, if you will. Like this is what it kind of does.
Why
This
does
will
it keep
help
coming
you.
back to food?
Yeah.
That's-
Glasses
yeah.
of water, meat and
Glasses of
potatoes.
water.
I'm food motivated. That's how.
No kidding.
Yeah. So I mean, for me, that's where I kind of start is the compressor, because when we mention AC, I find most of my students that's what they think of first.
The
is
AC compressor.
the compressor itself, and then that's kind of where I go off of.
That's the component that in their shops they've replaced and hope to fix it.
exactly.
That's why they know
That's
it.
the one shot.
Well, it's
No,
the main thing, I think, and we'll just throw.
I
throw
agree
it
with
at it.
Gully. The compressor is the heart of the system, but I think the compressor has to do two jobs. Number one, it has to move fluid or refrigerant through the system, because without it, you don't have this refrigeration cycle, which I'll kind of touch upon later.
Yeah.
And then it does have to create that pressure. And again, with a restriction, it's creating that increase in pressure. So
Which is imperative to
it
AC.
is.
Yeah.
I'll ask my students, why can't we just have a pump? Why can't we just have a pump moving refrigerant through the system? Why do we need it to raise the pressure? And then they start thinking about it, and there's a definite reason there. And it has to do with this heat exchange and change of substances when we get to their condenser and their evaporator. So I think the compressor is kind of like a two-role member where it does multiple things all in one to get that system working efficiently.
And so to start off then, we have a compressor. What state are we compressing the refrigerant in?
Well, we can never have liquid refrigerant go in. So
Why?
Well, you
we can't compress the.
We can't. Then it grenades.
Well, we
I've seen
can't.
it happen.
Yeah, we can't compress the liquid. Okay. Well. I mean,
so here's the thing. I am just kidding here. Like I get into the same thing when we talk about brake substance.
Yeah. Right.
We can technically compress a liquid, but then you need a machine about the size of the room that you're in to
Yeah,
compress a very
right.
small amount
Yeah,
of liquid.
yeah.
So it's not feasible.
Yeah, it's
to-
not
with the
practical.
amount of
It's
pressure rather that we have. So
Well. Yeah.
sorry,
all
I
right,
just
it's
had
all
to
right.
bust your chops a little bit.
It's fine. I get it. First timer. I'll get my third time jacket.
Come on, man. 3 times here.
Jackets. We don't have that kind of
Yeah,
money.
we're-
I'm
these
trying
jackets?
to say it enough so it happens.
I'm hoping to get like a ring or something.
A ring.
Get a Super Bowl ring.
Like we getting married? I don't know about this.
All right, so it goes in. So we have no liquid entering the compressor. So
Ideally.
so that's what I try to tell the students, because we can eliminate what's going in and what's going out. It helps them remember. So it goes in low pressure, and because we have our restriction, we create that pressure, and it comes out as a high pressure gas.
Okay.
And that's where I kind of start.
So
think
we
that's
would
great.
say that entering into the compressor is the low pressure gas, and it exits as a high pressure gas.
Yep.
Is there a change of temperature at the compressor? Compressor.
You got
Yeah.
that. You got that.
Well,
Long day.
this goes back into when we talk about heat and different, components and how they work. But then there's also a huge relationship between pressure and temperature,
Yeah.
and temperature and pressure, like vice versa, right? So
And all
if
the
you
laws,
get a
Pascal's,
gas,
Boyle's, Charles.
and then we talk about that. So
All my buddies.
We should
when
have
you
them on the
compress a
podcast.
gas in a confined space, it's inevitably going to create some heat or create some temperature. So yeah, it's coming out a lot hotter than it came in as a low pressure gas.
And that's where you make the mistake of putting your hand on the wrong, on the discharge line of the compressor.
Or that also helps you tell what line's what.
Yeah.
Oops.
This one's toasty. And this
Toasty, always food.
Yeah, I know. Oh man, it just comes to me naturally. I can't even think of other words.
All right, so the compressor, and you know, I'm going to kind of go backwards a little bit just for a quick second. And if we think of an orifice tube system, we have...
What's that?
It's a metering device, but we have a certain component on that, and that's the accumulator on the orifice tube system. And that is to capture any fluid before it gets to the compressor.
Yeah.
So we'll probably talk about that 2 different metering types later on. But if you think of that, that's an easy way to remember what style you have because of the orifice tube that can allow more liquid refrigerant pass through the evaporator at times. That's your capsule to say, oh, don't get to the compressor yet, so it explodes, right?
Mm-hmm.
So just an easy, when we were talking about that liquid.
So your easy way of identifying the type of system you have is based off the position of
the accumulator.
If there is an accumulator.
If there's an accumulator and
If
it
not,
would
then there'll
be
be a receiver
before the
drive.
compressor.
It would be before
Yeah,
the compressor.
So
if it's not
from
to be
the
a receiver
condenser
dryer.
or in between the condenser.
After the evaporator,
After the evaporator.
Accumulator.
Oh, I see.
before
Accumulator.
the compressor.
It's like a fail-safe, if you will.
The compressor's sucking refrigerant out of the evaporator.
Right.
And then it goes and gets compressed as a gas and then makes its way to the condenser. So if it was an orifice tube, it would have that accumulator before the compressor to protect it from any future or any fluid entering the compressor.
Yeah.
So it'll store any fluid, and the vapors are allowed to pass through and get to the compressor.
Yeah.
Okay.
Yeah.
And then on the TXV style or an H valve style, you're going to have an receiver dryer that's going to be mounted somewhere near the condenser.
Yeah, sometimes
And
even part of the condenser.
Even part of the condenser, and that's mainly for filtering debris and foreign
Moisture,
material and keeping
Exactly.
moisture out of the system.
One of the big things students struggle with is the difference between receiver dryer and
Right.
accumulator, and the fact that there's only one on the system.
Yeah.
Receiver dryer is always going to be high side, accumulator is always going to be low side.
Absolutely,
Right.
yeah.
So it's just,
Yeah.
if you kind of understand the system and kind of know what to look for, then you should be able to identify those systems super easy.
Yeah. Sometimes it's hard to look at the metering device and be able to see, what exactly it is. So I find looking at if it has an accumulator or receiver dryer is a quicker way of identifying the system, I find.
Sure. So compressor now, we started with the compressor. We talked about a bunch of other components, but after the compressor, it's leaving as a high temperature gas going where?
We will be going to the condenser next.
Yep.
And that's where the change
Right
of
to the
state
front of the car.
happens.
Yeah. And a condenser does what?
Condense it. So it goes from.
That's what my students always say.
Yeah.
sir,
I know.
Does it condense?
Yeah, and I always say
No
thanks.
kidding.
Yeah, and then I say thanks for repeating the
excellent.
word
Let's move
back
on.
to me to explain it. Well, it leaves we've established it leaves the compressor as a high pressure gas, and now the condenser is where the change of state happens. So it has to go back from a gas to a liquid, and that's through that process, through that temperature change, if you will.
Why does the temperature change?
Well, with the condenser's on the outside.
Okay.
But what
We're
is it?
hitting that. We're hitting.
What is it?
Me, sir.
What is a condenser though?
So condenser is just a heat exchanger.
Okay.
It's like an
good
evaporator.
way
It's
of
like a
explaining
rad.
it.
It's very similar.
It is a radiator.
It is a radiator.
Yeah.
And it's
exactly
normally
like
it's
one,
mounted in front of the radiator,
Yeah.
right? And it gets the initial gust of air or moving air from outside as the car's moving. But remember, going back to the compressor, because I think we're jumping ahead a little. I said it's responsible for 2 things. So number 1, moving refrigerant through the system, and number 2, increasing pressure. So my students always ask me, why do we have to increase the pressure? And here's the thing. So it's pulling refrigerant from the evaporator. We're sending it to the compressor, or the compressor sucking it in as a low pressure gas. The compressor is now creating a higher pressure gas as an output, right? As a compressor spinning. And that high pressure gas is now increased in temperature. So we actually need a temperature differential from the refrigerant that's in the condenser to outside air, because heat always moves from hot to cold. So we need this temperature to rise upwards of, 250 degrees or something like that in the front of the condenser, maybe even hotter. If we're going to do Fahrenheit, if we're going to do Celsius, it's a different story.
I'm glad you said Fahrenheit. I was like, wow,
no, sorry, Fahrenheit. So even if
everything's boiling.
even if we use Celsius, right? On a hot day, let's say it's what, 35 degrees, 40 degrees outside is super hot.
Absolutely.
Right? So we need something that's hotter than 40 degrees for the outside air to be able to remove heat from that condenser.
That's really well said. I
So
really like that.
that's what we have to do. That's why we have that pressure increase from the compressor. So, generally there's like 100-degree difference between outside air and condenser temperature.
Mm-hmm.
And that's how we get the actual refrigerant in the condenser to cool off and turn from a gas to a liquid.
That's really well said. I like that a lot.
Mic drop.
Yeah. Okay. And walks in.
Well, yeah, he's gone.
Where the hell is he going?
So he somehow found a SOT jacket.
They're working on it.
It's his champion on it.
They're sewing it together.
Oh,
Yeah.
okay. So I'm going to ask a question about the condenser still. How does it do that stuff though? Like you're saying it's got to release the temperature from the refrigerant to the atmosphere essentially, or the air outside. What we said, the conduction, convection, radiation.
Yeah, which you didn't really talk
We
about
didn't
what they
define them,
are.
did we?
Yeah.
So-
I guess not
Conduction would be like the transfer of heat through touch.
through a metal
Right?
or through an object.
To an
Yeah.
object. So
Contact.
like to be very simple, if you got a pot on the stove and it's hot and the handle's hot, you touch the handle.
Yeah.
That's conduction heat.
moving
Yeah,
through
it's
Even when you're
moving
told
through.
not to
from
touch it,
Right, yeah,
because
you're
it's
told
hot.
don't touch
From
it,
hot
it's hot,
to
right?
cold. Yes.
Convection is more so the movement through fluids and gases.
Yep.
Okay, so you got boiling water, all the water is moving around, it's creating heat, it's the molecules are moving faster. And radiation is the radiating heat. So if you're standing by a campfire or something like that,
Exactly,
you can
yeah.
actually feel that heat
Sure.
radiating off. So those are the three transfers of heat that we talk about. I think you were trying to get at that
Yeah,
a
the
little
way
while
the heat
ago.
can move.
Yeah, exactly. Yeah.
So I'll field this question if you want, because I think with the condenser, what we have is we have a series of tubes that run in parallel on the surface of the condenser, and each of those tubes have a series of fins that are now connected or in contact with them.
Mhm.
And as we have air flowing across, we have that transfer of heat through the tubes, through the fins to the air.
Mhm.
That's how we get rid of that heat.
So which of those three, conduction, convection, and radiation, does that use?
Oh, I would say at least two of them.
What do you think, Gully?
Oh, maybe is it all three?
It is.
It's
Yeah.
all three. Yeah.
We have
'Cause
gas moving through the tubes.
Yeah, we got gas moving.
gas or liquid. Then we have
Yeah.
air moving through the fin or the metal fins
Contacting the fins,
themselves.
yeah.
So it's transferring through
Absolutely.
that, and then you have radiant heat beyond that.
So we got all three.
Yeah.
I
So the
stand
same thing with
corrected.
the heater core, which is
Can't drop
which
the
is
mic
a fun
now.
way to think.
Yeah, pick the mic back up, please.
Yeah, and that's exactly why we need it at the front of the car for it to help with that. So, and sometimes my students they forget that a lot. Oh, I gotta talk into the mic.
Yeah, that would help.
Sorry, cut that. Yeah, I didn't leave that in, eh? Yeah, and that's why we have the condenser in front of the rack, because it's going to be blocked if it wasn't as well. So a lot of times,
What's going to be blocked? Sorry.
if you put the condenser, if the condenser was not in front of the rad, it'd be a lot harder to get that air through it and pull through it, and
Gotcha.
so
to
you know,
drop to
Just
change
get
the
that change.
temperature.
Yeah,
Get that-
exactly.
yeah.
Yeah, and then there's a whole other things we can get into about diagnosing and looking at the
We'll
condenser.
do another
so,
one.
yeah.
I'd like to do another one of these
Yeah.
for AC diagnosis. So
Sure. Yeah,
just kind of
absolutely.
fundamentals.
That's easy.
now.
Just charge it up. And let
Yeah.
it
Charge it up, fill it up, let it go. That R1, 2, 3, 4, 1.
Yeah.
Real super cheap.
Yeah.
Super cheap. Just top it off.
I got a bunch of R12 in my.
I get
back
students tell me that all the
shed.
time. It's like, don't tell me that. Oh,
Yeah.
Exactly.
The less I know about that, the better. If they,
Okay, so the condenser. So after the condenser, depending on the system,
right.
let's just say generically, we're going to go to what? From the condenser, or you know what? Let's go to a TXV style system, because the condenser may have a component on that itself,
Right.
Yeah.
which could be the what?
The receiver
dryer.
Receiver dryer.
Great. So a lot of
Yeah.
receiver dryers are built into the actual condenser itself
Yeah.
Mhm.
because it needs to be replaced with that.
Exactly.
So some of
Yeah.
them are external, and you can find them in the high side lines.
hmm
But that receiver dryer, what does that do? We kind of mentioned it earlier, but Gully, you want to?
Well, yeah. I mean, I always joke with my students. I mean about it because it helps remove the moisture in the system, because moisture in an AC system is not good. And I always say, it has like the desiccant, like when you buy your Jordan shoes, that
Yeah.
desiccant bag you get in your fresh
Oh,
Jordans.
that candy they gave you?
Yeah,
In the box?
the candy. I see that got me back to food again.
It says don't eat, but it
Don't.
tastes great.
But I wanted to see it.
It's a fake
It's
out,
a
yeah.
Milk is
lie.
bubbling.
And I say that material that you get in there is the same kind of material you can find in a receiver dryer. It's just absorbing the moisture in the
silica
system as
as well.
well. Yeah, exactly.
Yeah.
Media,
And-
some type of media.
Yeah, so they're good
Yeah.
at absorbing any type of moisture that may, and hopefully there's a minimal amount of moisture in the system because there's a couple steps that we can do to prevent excess moisture,
Yeah.
which I think we talk about as well in the AC course. So the silica, the gel or the silica beads or the desiccant bag is to absorb any leftover moisture that may be in the system. So they have a certain amount that they can absorb. There is some filtering in there, I guess maybe for some impurities or anything that's left in the system. And that's about it.
So what's the primary way to get you said that's an additional way to get moisture out of the system, but what's the primary way to get
Yeah, that's a
moisture
good
out of the
question.
system?
So when you're working with an AC machine, like the service machines, there's a couple different procedures and steps and functions on that machine. And you'll see like there's an evacuate button and then there's a vacuum button. And I feel like some students think that they're the same thing, but they're not. So evacuate is going to pull all the refrigerant out of the system and possibly any oil that's in the system. And then the vacuum, we can use it as a couple things. We can do it. Number one, we can use it as a leak test because if the system is able to hold a vacuum, you can pretty much assume that the system is sealed and it's not leaking for the most part. Hopefully,
It's handy. It's most handy when there's a giant hole in the system.
Yeah,
for
It
sure.
doesn't hold any
Right?
vacuum.
For
Then
sure.
you
Not so
know-
good for
smaller
very
leaks
small-
maybe, but
intermittent leaks.
But the other thing is, if you have that system on a vacuum for long enough, what you're going to do is you're eventually going to boil over any moisture that's remaining in
Yeah.
the system. So, as a rule of thumb, 30
4
minutes,
hours.
30
okay.
minutes, 45
30
minutes.
minute minimum.
Minimum.
Yeah,
Yeah.
30-minute minimum.
I've seen guys do 5-minute vacuums.
I mean,
And-
I'm guilty.
I'm also guilty of that too. But flat rate is flat rate. You kind of find your ways around that. But if I had a system where it's been working and it was full, it
That's
came in
exactly
full,
what I was gonna
and I
say.
got to change a part, I'm
Right.
100% going to swap the part and do a 5-minute vacuum and charge it back up.
Warranty doesn't pay for the
No.
vacuum.
But
so.
if I had a car
It
that's
does.
been
Does it?
It does on the yeah.
Like which vacuum?
There's an
Like
additional
the
law.
shop vacuum? Like
French
fries?
get your
gotta
Dyson
know
out.
your lops. Yeah.
But if it's a vehicle that you know that this system's been open for 6 months, 8 months, 10 months, you might want to do a longer vacuum than 5 minutes. It's
I
probably-
mean, and you should replace that component, that desiccant bag.
yeah, because that desiccant bag is
absolutely.
full now.
Unless you're cheap like me and I'm going to vacuum that for like 3 hours and just see if it works.
Yeah.
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 But when I was in the shop, I put a car in vacuum for 30, 45 minutes. I'd go to lunch. I'd go work on another car. Just let it do its thing.
Yeah, you can
Yeah,
plan your
right?
day out.
You can do something else while it's vacuuming. And then, that's one of the big methods of getting moisture, any excess moisture out of the system.
Yeah. That's great.
And then the desiccant is like a fail-safe for whatever may be left behind. And hopefully, if you've done it for long enough, there isn't much.
So the opposite side now of the receiver dryer, because we're on this desiccant bag and moisture and whatnot, is the accumulator. We talked about it capturing liquid before it goes into the evaporator, but it also does some of the similar functions, right?
Exactly.
It's got the exact same desiccant that you find in a receiver dryer. It is supposed to do the same thing and absorb some of that moisture.
Yeah, just in a different spot.
Yep.
Yeah, in a
Some
low
of-
side setting
Yeah.
instead of that high side
Right.
setting.
And some of them will have your pressure switches or your cutout switches built into as well,
Yeah.
which you might not find. Some of them also have sight glasses, which I think are kind of useless.
I don't think they're very common
That's
anymore.
usually on the
No.
receiver dryer.
Yeah, I don't
Yeah.
think I've seen.
Yeah, I've seen a couple on accumulators,
Yeah.
but I can never see into them. It's just like a dark,
It's like-
cloudy thing. What does this tell me? It tells me nothing.
Yeah.
I'm just gonna cut it open and see what's
That's true.
inside.
Yeah, I haven't seen one in a long time. Sight glass.
I mean, you're looking through them right now.
Yeah, I know.
You got
Coke
glasses
bottles.
They're just
not
it's
green.
true. Like Coke bottles. Yeah. So
Okay, so what do we have as the next component after that?
So the receiver dryer, condenser receiver dryer, and I guess we have to go to one of the
the metering device.
Well,
One of the
if we're doing
big-
receiver dryer, and then there's only one.
Yeah, there's
Right?
a huge component next. That's a kind of like not very understood, I would say.
Mhm.
Would be the metering device, and I'm glad you said that, Gully, because a lot of people say, "Oh, it's the expansion valve
Yeah.
or whatever." So I start every AC course I teach with, "Find me a metering device," and they're like, "What is a
What is
metering
that?
device?"
Yeah, yeah.
I'm like, well, it's gonna think of the name and like go and we do this like search through the lab trying to find something. And they're like, I don't know what a variable
Uh-huh.
metering device is, and it's kind of fun, but that would be the restriction,
Yeah,
right?
exactly. Yeah, I try to generalize it because I find a lot of the times they'll just, assume it's just the one on every car, and don't
Well,
think
there
there
is one on every.
Well,
one,
I
so-
mean, like it's just
Actually, there could be more. There could be more than one on there.
Yeah. I mean,
I got
So to sum up,
I got two.
You got one
of
two on your
each.
van, actually.
Yeah, that's true.
Yeah.
Caravan, that's true. Yeah, I guess when we're starting to teach AC, it's just easier to generalize it as a metering device, and then we can get into the specifics of what is unique about each one.
Can you explain what a metering device would do then?
I'll do my best to. I mean, it's like I always explain it like it is the restriction, but it also controls the amount of refrigerant going into the evaporator. We don't want to have too little or too much, so we need to control that
you need to
in a way.
meter it.
We have to meter it,
there we
hence
go.
the name,
Oh,
metering
yeah.
device.
So how does it vary the restriction?
Well, which one are we talking about first? Fixed
Up to
or expansion valve or?
Well, if it's varying, it can only be one.
Yeah.
yeah. Well,
it could be two. I got two.
Yeah.
Kidding.
well, I mean,
There can only be one. Highland, anyways.
Yeah.
well, so if a fixed orifice tube would be classified as a 1 metering device, and you can't change its size. So however it's set from the factory, the restriction size remains the same.
What's the downside of that?
Well, it's hard to say what the downside is. I mean, in a sense that, it has less moving parts, so maybe less likely to fail.
So that's the upside.
I guess that is yeah.
I guess that's
been
a
a long
tech
day.
answer.
Yeah.
He's like, the downside is it doesn't fail. I don't get to
sorry.
replace it.
I
I
was
make
thinking
money.
about expansion valves at the same time when I'm talking about fixed orifice tubes.
I would say with the fixed orifice tube, because it's a fixed hole, you don't have as much of control in terms of what's entering.
Well, you have
That's
no
good.
control.
You have no
Yeah.
control, exactly.
Yeah.
So you're relying
It's
on
fixed.
other factors,
Right.
which is kind of the reason why there's an accumulator on
Exactly
there, because
that.
there's going to be excess
Right.
liquid,
There may or may not be.
that may enter the compressor. So we have to have that fail-safe
If
device
you had
in
an
there. So
incredibly humid day or hot day where it's working like
Yeah.
crazy, it's going to need a
Right,
different
yeah.
amount than if you can't. And if that's
Yeah.
fixed, nothing gets
Exactly.
changed, right? So
Yeah, we don't. Yeah, there's no way of changing it compared to the expansion valve, which you can change.
exactly.
How do we do that?
magic.
Magic.
Wizards.
Well, it's not actually. Let me tell you how the expansion valve works. I'm kidding. Go
Yeah.
ahead, Gully.
But
I'm kidding. I'm not going to tell you. It's a secret.
Well, no, it's not true at all. And one thing that we need to remember is what do we want to measure with the metering device, right? We need to measure something so that we can calculate how much
Yeah.
or the size of that restriction. And we have to measure a temperature essentially.
yeah,
So there's two types of expansion valves. There's an H block,
right.
and then there's the capillary
The old
tube,
style capillary tube,
that
yeah.
we
Which
don't
is-
see too much.
It's the same principle.
It's
It's just,
identical.
they've just modified
We just
it
have
to
a
make it
little
look-
wire
yeah,
with a gas-filled bulb
Yeah.
that's
Yeah.
taped to the
outlet
where?
of the
Outlet of the
evaporator.
That's a
evaporator.
huge thing.
Yeah.
And for any student that's taking a course in AC, the outlet of the evaporator
Yeah.
needs to be where that expansion valve is going to be measuring,
Yeah.
right? So if we think of an H block, that's all one unit. It's kind of
Exactly,
a
yeah.
machine piece. And if you are a student here and have electude, I suggest you go through the expansion device electude because it does a great
does it,
job
yeah. It's
kind of
fantastic.
watching through, and you can move through and you see the insides really well. But if you have an H block, that both the inlet and the outlet are together.
Yeah,
They're
exactly.
going through that H block. So you're going to be able to meter it on one side and monitor it
Yeah,
on
the
the
other side. Yeah.
So with the capillary tube, we have a wire and a bulb
Yeah.
that gets hackily taped to,
Yeah.
Yeah.
Exactly.
The
Well,
outside
SSB
outlet
has,
of the evaporator.
Exactly.
So
Yeah.
with any AC system, ideally we're trying to keep the evaporator at a constant temperature. With the fixed one, with the fixed metering device or orifice tube, it's a little harder to keep it at that regulated temperature, especially with outside circumstances, temperature, humidity, things like that. With the variable one, it's a lot easier and a little bit more efficient at keeping that evaporator at a steady temperature. Number one, we don't want it to get too cold because we're going to get evaporator freeze up. And we don't want to get too warm because then you're not getting cold air. So we're constantly trying to monitor or regulate the amount of refrigerant flowing into the evaporator by monitoring what's coming out. And the thermal expansion valve or the H valve or the TXV, whatever you want to call it, they do a pretty good job of doing that on the fly and being able to adapt to different conditions to get that evaporator at a steady temperature.
Yeah.
I tell my students as a general rule of thumb, if we can get our evaporator, and it's I give them a range, in anywhere from 1 to 7 degrees Celsius, you're going to get sufficient cold air.
Yeah.
And that may not sound like cold air, but 7-degree temperature on a 37,
Exactly.
40-degree day, that's going to feel pretty cool. So if we can keep it there, if we get any lower than 1 degree, now you're going to start to get freeze up. And freeze up is moisture and, accumulation of water on the evaporator. And that's another thing because humidity is a big factor on how our AC systems work.
Mhm.
Well, yeah, and if the evaporator is a block of ice, it's not
Mhm.
going to really work too
Yeah.
well.
Yeah, you said ice up.
Yeah.
That's a legit thing that happens.
Mhm.
And what is that? What happens with that?
So I'm sure most of you, students out there, everyone listening to the podcast, you drive in a car, it's got an AC system, you're going to notice there's drips of water coming from the car. And that's just a natural byproduct of how the AC system works. That liquid has to go somewhere. So there's normally a drain that's hopefully not plugged and it's dripping onto the floor.
Where is this liquid coming from?
Exactly.
Yeah.
What is
What
that
is that?
liquid?
That liquid is essentially moisture from the atmosphere.
Humidity.
Humidity.
Yeah.
Yeah.
Right?
From inside the cabin.
From
Yeah,
inside. Well, yeah, it
exactly.
depends, right? Because you also have a recirc button on the car. And you can have it, So that's another thing I talk about. But yeah, it's essentially moisture from either inside the cabin or outside air. And that moisture is going to collect or accumulate on the evaporator. And then it eventually drips down. If it's not cold enough, it'll drip down as a water form. But if we get that evaporator too cold, that liquid will actually start to freeze up.
So it's like the condensation that would build up on your
Water glass.
glass of
No,
water.
not at all. Actually.
no.
It's the
Yeah.
opposite.
That's the opposite.
different?
That's going the other way.
What it is more when is anybody taking an aerosol can and
Yeah.
expelled it fast?
You get the cold.
Sure.
you get the
Because
cold
you
air.
have pressure now that's going to a low pressure, a high pressure, low pressure. And if we
Wow.
think of our restriction or our metering valve, we have a high pressure gas that's now getting cut off. And I like to explain the metering valve like you on the highway. So if you're driving on the highway and all of a sudden there's an accident in front of you, what happens? You get all that pressure built up.
Exactly.
Cars
Yeah.
like crazy.
Mhm.
As soon as you pass that restriction in the highway, what do?
Speed up.
140 and
Yeah.
fly.
Never.
Like, you're just going as fast as you can. And that's basically what this is doing. You're taking all this liquid that's being pushed up against this restriction, building that pressure from that compressor. It's now restricting it so that only a little bit can get by and then it can speed past. And when
Yeah.
it does that, it gets cold,
Yeah.
right? We have that drop in pressure instantly, just like on the highway, you're going from stop and go traffic
Right, yeah,
and
exactly.
hate it. And then as soon as you start flying, you got that cold air whipping across you.
So
right?
much room for activities.
Yeah.
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 Activities.
Yeah.
Oh.
Yeah.
Step Brothers? No.
Yeah. What could go wrong? So we have that refrigerant that's moving now very fast past this restriction.
Yes.
Why does that cause the water to build up?
It's not the water to build up. It caused that condense. Like I said with the aerosol can, when that expels out, it's gonna kind of condense on that can, right? That's what's happening
On the outside of the can.
On the
Right.
outside, yes.
Yeah.
Exactly.
So yeah. It's a yeah, exactly. I don't know.
Exactly.
I wanted to,
To
chime
sum
in
up-
there.
Exactly.
Well, chime in there. Go ahead.
No, I was just gonna say. Well, yeah, it's just like the evaporator is gonna get cold. They're gonna build condensation up, like exactly
Yeah.
what we're talking about.
Perfect.
So that's where we're getting the moisture, and hopefully you have a clean drain.
Clean drain,
too. Yeah. Or that water's gonna sit. in
And
there.
you know what? I have seen vehicles where the inside of the cabin, the carpet's all wet.
Yeah.
There's moisture everywhere. And all you do is just blow that drain, a little bit of, cobwebs and debris
Yeah,
come
debris,
out
dirt,
and water's
leaves.
pouring
It's
out.
disgusting.
I've had customers come in saying it sounds like there's a fish tank in my car
Yeah.
because they're driving around and all this water
Sloshing.
sloshing around in the H box, and it has that like musty
Mhm.
smell. You're like, oh, I know what this is, and you go check the drain tube,
Yeah.
and it's plugged up, right? So
Yeah, and I'm sure everyone's had customers complain of a leak on a new car and had their AC on as well, and they
Yep.
see the water, but they don't realize it's
no
just
fault found.
Yeah.
part of the process of the AC.
Need a water pump, sir?
Yeah. And so what you're talking about is that drip
That
in the
drip,
summer,
right.
right? It's the
Exactly.
humidity leaving that HVAC
Yeah,
box
exactly.
through that drain.
Yeah.
And everybody's like, oh no, what's leaking there?
Exactly.
And then
Yeah.
you go lick it and it's just water.
Yeah,
And-
it just tastes
yeah,
like
I'm kidding.
Back
some
to-
oil, maybe some
Yeah.
dye.
Yeah,
Uh,
exactly.
Okay, so
Um,
we've kind of came back to the evaporator. So let's finish up all the components now with that evaporator and what it does. So what's the evaporator and what does it do?
Ooh, that's where the next change of state happens.
Okay, and it's in the name.
Yeah,
Yeah,
it condenses.
evaporator.
It melts. Yeah. Plasma?
So now it's now I'm going to say it because it's in my head. It's evaporating, but now that's the second place the change of state happens. So we have the condenser. It goes from a liquid to a gas. So that means in the evaporator it has to go from
No, I think you messed that up.
the other way around. So it has to go from a liquid No, I just said that.
So the condenser
Sorry.
gets
Yeah,
gas.
Yeah,
Yeah,
see, I'm running.
Turn it back,
Make sure we
Lopes.
cut
Okay,
that.
it's my third time around. I can fix this.
Yeah.
So it goes into the condenser as a gas, leaves as a liquid, right?
Yes.
It cools down and condenses. Now that liquid hits our metering device, which would be our TSV,
And it stays
or
a
H-valve,
liquid.
and it stays a liquid,
Yeah.
but it drops in temperature, or drops in pressure because of that restriction. So now we have cold refrigerant entering our evaporator as a
As a gas now. That's a liquid. Sorry, turning to a gas.
You know what? I love this so much because teaching it, you're like gas, liquid,
Yeah.
and then you're like, wait a minute, what did I just say? And
I do that all the time
I
in
get caught
class.
up, and I'm like, and the guys are like, sir, you're backwards. I'm like, I know. I just get it.
I was
Okay.
testing
Yeah,
you.
it happens after you've been talking about it for 2 hours. You're like, oh.
Exactly.
Yeah.
So the way I always remembered is if it's evaporating, you can't evaporate a gas into a liquid. That's
Yeah.
not the right way. So we have this cold, low pressure gas entering the evaporator. And again, the evaporator is another aluminum radiator-like
Yeah,
device,
exactly.
like
It's
a
just
condenser, just doing a
yeah,
different
smaller
thing.
scale.
It's a heat exchanger, and we are blowing hot air across the fins of the evaporator
How do we do that?
and with the blower motor inside the cabin air, right? Yeah, you're not just all 6 of you in the car
There we
blowing
go.
on it. That's
So
not
we
gonna
got our
happen.
additional
So-
component, the blower motor is a factor as
So
well,
yeah,
right? We
So
can't overlook
we're moving
that.
air, and now there's also 2 things. It's where's that air coming from? Because you can have the air coming from the outside, or you can have it coming from the cabin. So a lot of times, you'll have this little funny looking reset button on your car that if you get in an accident, you press it, everything goes back to normal.
Oh, is that what you do?
No, but that's recirculation, and what that does is that's pulling in cabin air and blowing cabin air. So what's already in the car across the evaporator fins.
What's the benefit of that?
It's more so efficiency, because ultimately, if you don't have that, you're just trying to cool the world with your little dinky.
Well, that's what we're trying to undo global warming.
Oh, yeah, that's true.
Start your cars, boys.
Okay, no one use recirc anymore. Everyone have it on fresh air.
And if you have it on max AC, it does that automatically.
Yeah, a lot of cars
Yeah.
will automatically
Yeah.
do that. So here's what I try and get across to my students is that you've got hot air in the car. Let's say you come up to your car, was sitting in a parking lot all day. The sun's been beating on it. You open the doors, you can feel the heat. It's much hotter than outside air. But when you start your car up and you have it on recirc, you're taking that hot air and you're blowing it across the evaporator. We've got cold refrigerant coming in. It's going to give us some sort of cool air and start to feel nice in the car. But we're actually getting rid of that heat from inside the car, and through the process of that AC system refrigerant, we're sending it back to the front of the car to be expelled to the condenser and to the outside air. So
we are global warming.
we are global warming.
It's all
Dang
our
it.
fault.
And then so like you said, what's the advantage of it? Number one, if you had a really hot day and you had it on recirc, you're pulling in your hot air, and eventually it's going to get cold. But now you're going to throw cooler air across the evaporator, so it works a little bit better. It's more efficient. But if you had it on fresh air mode and you're pulling 40-degree temperature outside all the way through the car, this system's going to have to work a lot harder, and it may not get as cold as you would like it, as if you put it on recirc.
Mm-hmm.
Absolutely.
And you should be aware too, I guess, that sometimes, and this is I've seen as a customer complaint, where they're saying that their recirc comes on and off and blower speeds change.
Yep.
So if you leave it in automatic,
Yeah,
it may
it's gonna
turn
do that.
recirc on and off because the air gets stale.
It gets stale. But here's another thing. I also ask my students, so, going back to our first question, what does air conditioning do? How does it condition the air? But what else does it do for our cars? And that removal of moisture and humidity is a huge factor on cleaning our windshield and cleaning our windows when there's fog or, defrost on there. So you may not notice it, but in the wintertime, you turn your defrost on, right, to clear the front windshield, your AC's kicking in to remove moisture and blow
Which is a
dry air on the windshield. So
reheat system.
Yeah.
So now it's kind of a safety feature too. Not only comfort or cabin comfort for passengers, it's also to give the occupants the best visibility when you're driving down the road.
I would really like to get into that more in the next AC podcast because that reheat system is really neat. And then automatic climate control is actually
that's
really cool.
Yeah.
When you think of all the inputs and everything it does. So I'd love to get into that.
Yeah, that'll be my 4th podcast. I'm down.
So let's just recap the fundamentals of AC and from the compressor all the way back around, and it just keeps going back around and around and around, right? So so compressor goes into the compressor as a low pressure
I want
gas.
Gully to do the recap.
You want me to do the recap?
Yeah, let's do it. Let's do it.
All right. So we left off at the
High pressure to a high pressure to a high pressure.
Okay, so we're leaving it. Okay, we left off at the evaporator. We talked about the evaporator, so it's leaving the evaporator. Now, depending on the system, right? Where it's going to next, it could be the accumulator, and then potentially, if not the accumulator, then it's going to go back to the compressor. And then if you go back, we know that liquid can't enter the compressor, so it's going to enter as a low pressure gas because we have that restriction. It's going to help build that high pressure. And then from there, we're going to go to the condenser. Let's go from high pressure gas to a liquid. And then we're going to go through there. Depending, again, what system you have, it's going to go through the receiver dryer. And then from there, it's going to go to your metering device. And bada boom, bada bing.
Bada boom, bada bing. What happens there?
That's it. No further questions. Yeah.
All right.
Something like that.
So one thing that a lot of students struggle with is that metering device. So it goes from a high pressure liquid to a low pressure what?
So that's a great question because if I remember we look at the console labs.
Yeah.
We were looking at like the orifice tube. They think a change of state's happening in that orifice tube, but it's kind of like a mist. We're changing. It's like a restriction.
Almost droplets at that point.
Exactly. Right.
You think of those cars on the highway.
Yeah.
They're compacted,
droplets.
and then they
they're
just
still cars.
Fly. Exactly.
They're droplets now. This is getting offside.
Yeah, because they think, it's a change of states happening there, and it's like, no, it's not. No change of states happening there. We're just controlling the amount of liquid entering the evaporator now. So it looks like a mist. So we comes in high, and we're kind of building it to go low. We're controlling. Well, yeah, that's a whole nother podcast, but
that's like Elon Musk podcast you were talking about earlier.
I love it.
Yeah, so
not the high part.
No. Yeah, so I think having that visual helps as well, or sometimes it might confuse them, but we're just changing it from our high pressure liquid and bringing it down. We're kind of doing our best to control the amount of liquid entering the evaporator, because if we don't have any kind of control of what's entering the evaporator, again, we can have that problem with too much entering, could freeze it.
So we're turning
too little,
it from a high pressure liquid to a
low pressure liquid.
Change of pressure, but not change of state.
Exactly.
Yeah.
The only change of state's happening in the condenser and the evaporator.
In the name.
Right? In the name.
Exactly.
So that's all you have to think about it.
Right.
Yeah.
The rest of the system, we have change of pressure, high and low, low to high, right? Being your compressor, your metering device. So
exactly.
Pretty much what we described is what we refer to as the refrigeration cycle, and it just keeps going.
Yeah.
As long as you have that AC system on, it keeps going around and around and around. So again, typically on a lot of cars that come in with not cold enough air, or not blowing air at all, warm air, whatever, it's because a refrigeration problem. Normally there's a leak, and the leak is leaked out all the refrigerant into the atmosphere, and now there's no media to go through the system to have the change of state to be able to absorb heat and discharge it. The system's not going to work.
I think we did an okay job with the fundamentals.
I hope so.
Yeah.
I'm confused though.
Yeah, so it's a high pressure to a high pressure, right? No.
Just wins podcast.
I'm just going to put the windows down.
I love it. So, Mr. Gullison, you have never been on the podcast.
I haven't, and maybe not invited back again. After this,
we have to do part 2 of the
Okay,
AC
part
podcast.
2.
I love it.
Yeah.
So we've asked everybody so far 2 questions, and then we have a season 2 question that we're going to ask Alister here. But if you could be one person for a day, fictional, real, or dead, who would it be?
Oh boy,
J. Demi.
I did that as my joke answer for last one. Remember? I don't know if it's going to make it into the edit or
I
not.
don't think I could walk in his shoes. For pants wouldn't even fit either.
Okay, keep going. I don't want to edit this, please.
No, you're gonna have to definitely edit that.
I'm not.
That stays in there.
You're going to have to edit.
I'm not. Okay. Let's go. Okay,
Subscribe. I don't know. I don't know.
To sum up, he does not know.
No. I would be Superman. Why not?
Okay, you know what? I'll accept
Superbad?
it. Superman.
Superman.
Well,
I was like,
I heard Superman too.
No.
Which one? There's 2 of them. I mean, I'm leaning towards one.
Yeah, there's one that stands out as the winner. No,
so which Superman?
that's a great question.
There's only one right answer.
I would go with the Christopher Reeve version.
That's the right answer. That's correct. You are correct.
Henry Cavill or Cavill.
He did.
I don't even know who that is.
He's handsome.
It's good.
Yeah, he's a
Anyways,
good-looking
But
dude.
he's no Christopher Reeves. Sorry.
Gotta go with
Okay,
the original.
The second question, you could have any vehicle money could buy, and you get the Matrix download information So you could drive it. What would it be?
You're getting back that PT Cruiser.
My students always ask me.
Bringing it back.
Oh, man. That's a good question. It always changes. I don't know. Now I'm making all these weird noises in the mic.
It's okay.
I have a caravan. It's pretty. I would be happy with a truck, honestly. Nice pickup truck. I'm pretty.
Wow.
I'm pretty
is like
simple.
the most like
I know.
humble
I know.
answer.
I know.
This guy here's got a $15 million jet that he'd be flying around.
No, way
I
more
know.
than
More
that.
than 50?
Yeah.
It's like
120.
way more than that.
Oh, really?
Yeah,
Like a fighter jet?
Yeah.
Yeah.
fighter?
Okay,
Yeah.
I guess that makes sense.
I said,
and-
like those race dune buggies.
And Alan
I wanna drive.
McClellan said, what was it? Some jet that was worth like 250 million or something.
yeah.
Oh, interesting.
I'll take
They're more
a,
exciting than mine.
1993 Ram.
Yeah.
Without
a
AC.
little rust.
Without
Just a little rust.
AC.
I'd
Without
be
AC.
happy with that. If I can,
All right,
throw
and then,
some-
and the new question now.
okay.
The favorite.
He's going to answer all three questions?
Yeah, he's going to
Why
answer all
not?
three.
I-
And your favorite ice cream flavor.
Favorite ice cream flavor.
And Alistair,
all
the
of
same
them.
question goes to you.
That's easy. I already got
All
it.
of them?
All of them.
31 flavors.
I gotta sample them all and put them in. Oh man, you know what? I always go for the mint chocolate chip. Yeah.
Mint chocolate's a good call.
Yeah.
Yeah.
Good call.
It's my default usually.
All
Mine's chocolate chip cookie dough.
Mm.
Okay.
Chocolate chip cookie dough. I can't do it.
No?
No?
I
But
would-
you know what?
It's in my head about eating raw cookie dough.
Mhm.
Oh, I do it all the time. You know, on those
Like
packets?
the raw cookie dough?
Yeah, no,
Or
you
the-
know, you buy the Pillsbury. It says you can eat it raw now. Like before, it was like,
No.
don't eat it. Yeah.
Yeah, it's
No,
a
I
hard,
do.
that's a hard pass for me.
But if I'm
Texas
like, it
size,
depends
no.
on where I'm going.
Texas size no.
No, yeah.
I love
So,
it.
and then actually, I have an additional question. If you could go anywhere in the world, where would you go?
Oh.
Ooh,
Spend the day.
good question. Just the day?
Just a day.
It'd have to be somewhere I could go like deep sea fishing.
Okay.
So like I'd love to go like catch like blue marlin or something like that,
That
or
would be
sailfish.
awesome.
So
Yeah.
any one of the coasts where I could do that. Mexico,
Sure.
Florida, wherever.
Mr. Gullison?
If I could go anywhere,
Yeah, it's the same question.
This is four questions for
I have
Gully.
4 questions,
Yeah.
eh?
Does it- In his 1993 Ram.
Yeah, 93. No,
That's how far it takes him.
93 Ram headed to Texas. No, I don't know where I'd like to go for a day.
Come on, think.
I'm gonna think. Like, how about to spend with someone? Can I do that?
With D'Amico?
Yeah, exactly. I'd love to spend the day.
And where are you gonna go?
So we're gonna go. All right. If I could spend the day anywhere I like, I think I'd like any kind of track. I used to do that quite a bit when I was younger, but you know, having a family now, it's harder to have those adventures out. So nice track day. Watch some cars go around.
Did you used to do some like demolition derby stuff?
I
too?
did used to do demolition derbies. I did.
We should make that happen again.
Yeah, that's
Yeah,
pretty cool.
it's really fun. Yeah, that college did sponsor me, but yeah, no, it was fun. I highly recommend it. Yeah.
Great.
Yeah,
Well, thank you guys for jumping back on. It's been a fun one.
I think so.
I think we went for a fair while on this AC topic. I know we talked
Yeah.
about skills too, but we're over the hour mark. It looks like
Wow.
ish. So
And there's still a lot to cover.
There's
so
a lot to cover. Yeah.
Podcast 4, I'm ready for it.
Yeah, you're on.
Awesome.
Yeah.
Tomorrow.
I love it. No. Well, guys, thank you so much for jumping back on. Alistair, it's how many now?
3.
3, so we're going to be 4 soon. And the first podcast from Mr. Gullison, first of many, I hope.
Yes, me too. Thank you. Wow, it was
Not
great.
before my
Blast.
4th.
Yeah. This has been
I'll
a
catch up. Don't you worry.
No, it's been a blast. Thanks for having me, guys.
This has been the Talking with SOT podcast with Harnek Gill and Ian Campbell. Thanks for listening.